Hello, my name is Jose Marquez Jaramillo, and this is my video submission for Programming Assignment 1. As you'll see, I've created a Jupyter notebook in order to illustrate all of the methods. What I've done is I've created a class called data within a file called pipeline. In order to create a new instance of the class, all I have to do is indicate the file path for where the data is and indicate the column names that I want to use. Loading the data is done by calling a method called load data, and it tells me that 699 observations have been loaded with 11 features. Now, if I want to add missing values, in order to illustrate what I'm going to do is I'm going to look at a feature in particular and see if there are any missing values within the feature. Then I'm going to add or fill the missing values with the mean value of that particular numerical feature. And it is going to tell me 16 values have been replaced in nuclei with the mean value of 3.54. And then I'm going to scan again for that particular feature and see if there are any further question marks or not. And it doesn't have any. Now for ordinal mapping, the way in which I'm going to demonstrate is that I'm going to take a feature which is ordinally mapped from 1 to 10, and I'm going to reverse the ordinal mapping from 10 to 1. The way in which I do that is through this method called ordinal map, and I'm going to send the order in which I want to map the features. And you'll see that initially it starts at 1, has a lot of 1 observations, and now it has a lot of final observations at the back, meaning that the order has changed. Now for one-hot encoding, what I'm going to do is I'm going to look back to the nuclei feature, and what I'm going to show is that initially the column names are the original ones that I initialized when I created the instance of the class. Now, if I look at the first observation, it's also the same as provided by the initial data. And once I do the one-hot encoding, what you're going to see is that the nuclei feature is going to disappear from column names and from the data, and a one-hot encode for that particular feature is going to show. So the column names, you'll see that the nuclei one has disappeared, and we've added all of the labels corresponding to that particular feature, and each observation now has a one-hot encode for all of the labels. Discretization, here we have two different options. So one of them being equal frequency. For equal frequency, we would want bins which have maybe different widths but have the same frequency. So once I implement that, you'll see that in the histogram, that's exactly what happens. For equal width, we don't care so much about the frequency, but we care that the width is the same. So that's exactly what happens here after I implement the discretize method. In order to get going with the cross-validation and all of that, what I've done is I've split the data between training and testing data, and I've created attributes within the class that store that data. And since this is a classification problem, we need to stratify the sampling. So this is the initial distribution of the sampling. And now let's take a look at how the training data looks after the splitting. And you'll notice that it's just about the same with a proportion of 80% belonging to the training data. And then for the testing data, same distribution as the original data, just at a smaller scale, meaning that the stratification here is working as intended. Finally, standardization. You'll notice the initial mean value for this particular feature is 3.924. Once I'm done on the training, the mean is 0 and the variance is 1, meaning that it's been standard or made standard. And then for the testing data, similarly, the mean approaches 0 and the variance approaches 1. Now, for cross-validation, since this is a classification problem, we also do the stratified sampling. And you'll see that we have two class labels and that the distribution on them is the same across all of the folds. For the training set, is the same. We have the same distribution across all of the different folds, meaning that it's been stratified correctly. And then what I wanted to show finally is the cross-validation itself, which I have implemented down here. And it is based on the null model that was instructed in the programming assignment. And you'll see that we just take the majority class, which is going to be 2, and the error is going to be 0.6529. Okay. When I do the same for regression, as in the case of the Avalon dataset, what I return is the actual mean square error for all the classes.